Hello everyone. So in this video I'll be explaining to you and giving you a couple of examples in how we solve various types of trigonometric equations. So now here we are given, as you can see, an equation of cosine of x plus pi on 6 equals negative 0.5, given that the domain is between 0 until 2 pi. So no 0 and 2 pi not included, and then it's something to be noted that it means that our solutions must also be in radian measure. Okay, so if you're not used to using the radian, it means it's your time to practice in dealing with such a question. So in dealing with this equation, I typically will advise that we assume or we let that the x plus pi on 6 is basically its a. Why? Because we are more used to in solving such a question rather than such a question given here, like x plus pi on 6, or let's say 2x, or a question like this, for example, as well. So in the case of this example, so I rather have it as cos A equals negative 0.5, and then therefore because of that, so then we have the two possibilities. Where is it in quadrant? Which quadrant it is where cosine will be negative? It's in a quadrant 2 and in quadrant 3. So these are the two possibilities, right? So then note also that I put it as the a in quadrant 2, a in quadrant 3. So it's not the x, but it's the value of a that will be in quadrant 2, or the value of a will be in quadrant 3. And that is an important detail for you to see later. So then because of that, now we see that, okay, since the a is in quadrant 2, so what does it mean? It means that the value of a, if you use your calculator, you go cos inverse 0.5. This is usually how I put it. So the value of a, this will give us, sorry, I'll just erase that. There'll be pi on 3, or that's 60 degrees, right? But in quadrant 2, it's between 90 and the 180. So how do we get that? We look at the property again. So it's pi minus pi on 3. Or in the quadrant 3, it means that a should be pi plus pi on 3. This will be 2/3 pi. This will be 4/3 pi. However, that the a itself is actually x plus pi on 6, right? So x plus pi on 6. X plus pi on 6, which means the x itself is 2/3 pi minus pi on 6, or 4/3 pi minus pi on 6, which gives us 7/6 pi, and here it will be half pi. So these are the two answers. So you see, and then if you try to check back and then you just substitute back, it will give you the correct answer. So these are how you deal with. Of course, in terms of how you write it, it might be different from one and another. I'll put it the more generic and then simple way. Again, the important notice will be here, because this is where the quadrant properties coming in. The pi minus for quadrant 2, the pi plus for quadrant 3. In the way I should write it, maybe I can do it a bit more detailed, but for the sake of simplicity, I'll do it this way. Okay, let's move on to another case, another example. So in this case, please ignore this. This is from the previous discussion. So we have square root of 2 sine of half x plus pi on 6. So similarly as before, let's change it first. This, so then it's easier for us later. So sine a equals 1. So then sine a will be 1 over root 2, or that means half root 2. Again, it's a radian setting here, but you see that it extended. Instead of just 0 until 2 pi, it's 0 until 4 pi. So it means that we need to do another rotation later on. So here, if we do the a, which is the sine inverse of half root 2, that will give us pi on 4. Now the value of sine is positive, right? So that means it's quadrant 1. So it means a in quadrant 1 or a in quadrant 2. So you have to memorize it and be very good at it. So that means in quadrant 1 it's just so it's just the pi on 4. You got it? Or in quadrant 2, that means that a will be pi minus pi on 4. Right? It means it's a 3/4 pi, which if you change it into the original equation, it will give you this, right? And then you solve the simple equation again. So this will be giving us what, 312 pi minus 212 pi, which is pi on 12. Well, here it's giving us 912 minus 212. So it's a 712 pi, which means our x will be pi on 6, or our x will be 76 pi. So we get two answers, but we see that the domain that's given is until 4 pi, but we're only touching until 76 pi, which means it's less than a half way, right? So then how do we get the remaining half? So to get the remaining half, so logically like this, whenever we have the graph, if you try to sketch the graph of square root of 2 sine this, so you see that this period, you see it's a half x rate. So that means the period will be 2 pi over half. So you see the period is now it's becoming 4 pi. So that means up till 4 pi, that's one cycle, right? Like this. So then it's something to be considered. So if you want to go through further, so what you can do instead is that you add by 2 pi over here. You add by 2 pi over, not the x, but it's the a, right? So then that means it's giving us, the other possibility is a equals pi on 4 plus 2 pi, which is, it's giving us 9 over 4 pi. Then you try to convert it again into this. Then we do the same thing basically. Like this. And then 25, 12 pi. In other words, we get the x is 25 over 6 pi. And then we just assess whether it's okay or not. But since you see that it's actually x over 2 pi, so one period, so it means that when the question is about 1 or half, it means it's already giving us all the solution that we need. There are two solutions only. So that's how you kind of look into it. So these are two examples. Hopefully that's helping you to get the idea of how to solve equations of trigonometry better. Thank you.